Hey everyone! So we're going to continue with our unit on matrices. This is actually going to be probably our last week talking about matrices. So we talked about how you can solve a matrix and get it into reduced row echelon form. And what that looked like was the following. We had ones across the diagonals, zeros everywhere else, and then the constants were our answer values, right? So we talked about getting our matrix in reduced row echelon form using Gaussian elimination. So this was one method. Another method that we used to solve for the variables was Cramer's rule. So Cramer's rule was dx over d equals x, and dy over d equaled y. All right, so those were the two different methods we used to solve systems of equations. Another method we actually talked about as well, in addition to these two, was we also talked about inverse matrices, where if we were given a matrix, so we'll just come up with a random matrix. Okay, this is not intentional, this is very random. All right, I'm just making this up. All right, so the way that we solved for x and y was we solved for the inverse matrix. So we ended up turning this into our inverse matrix. So if this was A, we found A inverse, and we had xy would have been equal to A inverse times the constant matrix, and we would have eventually found what x and y were. Okay, so these were actually the three different methods we've talked about. We had inverse matrices, we had Cramer's rule, and we had Gaussian elimination and getting our matrix into reduced row echelon form. All right, so keep these in mind. All right, so now let's actually delve into this. So we're going to now use some application pieces to actually solve systems of equations using matrices on some real-life applications. All right, so our first question. We have a parabola passes through 3 points shown on the graph to the right. We want to write a system of equations that can be used to find the equation of the parabola in the following form. So we're just trying to get it into standard form. Okay, well, let's take a look at each of the points we have here. So we have the point 1, 4. We have the point, this is for A. For B, we have -2, -5. And then for C, we have -1, -6. All right, so let's plug into our equation. If I have f of 1, right, if my x value is 1, my y value output should end up being 4. Okay, so let's see. We have a times 1 squared plus b times 1 plus c. Remember, the output is 4. So I have a plus b plus c. And remember, f of 1 is 4, so we're setting this equal to 4. Okay, so there's one equation. Let's come up with another one. I have f of -2, and we know again that the output for when x is -2, its output is -5. All right, now before I go any further, I'm just going to clean this up a little bit. So I'm going to write our first equation here, just so I don't run out of space on the top. All right, so our first equation, we have a plus b plus c equals 4. All right, so now let's take a look at f of -2. Okay, so for f of -2, remember the output is -5. So I have a times -2 squared plus b times -2 plus c, and this whole thing equals -5. I have 4a plus -2b, so we're just going to write minus 2b plus c equals the output, which was -5. So there's my other equation, and I'm going to write that below here. I have 4a minus 2b plus c equals -5. All right, let's just get our last equation. Notice we're solving a system of equations where there's 3 of them. So we're solving a system of 3 equations. All right, so let's just clean this up. All right, now the last point we're going to check is when x is -1, our output is -6. So I have f of -1 is going to equal a times -1 squared plus b times -1 plus c. So we'll end up with a minus b plus c equals the output of f of -1 is -6. So here are my three equations. I have a minus b plus c equals -6. All right, so now we're going to solve a 3x4 system of equations. So hang on a sec, let's clear this up and let's make our augmented matrix. All right, so here's my augmented matrix. Now, when we have a 3x4 matrix, it is going to be way more steps if we get this into reduced row echelon form. So let me just show you what reduced row echelon form is for a 3x4. But in the end, we want to get this into just row echelon form. All right, so first I will show you what reduced row echelon form is for a 3x4. So we would have our 1s along the main diagonal and 0s everywhere else with our constants on the right-hand side. Now this is going to take a lot of time. So while you could do this, to save ourselves some time, we're not going to do reduced row echelon form. We're actually going to get this into just row echelon form. So let me draw out for you what that is. Okay, so this is actually the form we're going to want to get this in. Like I said, going to save us a lot of time if we just get this into just row echelon form. Be careful, not reduced. We always do reduced row echelon form for when I'm dealing with a 2x2. All right, because this is a lot simpler to get into reduced row echelon form for a 2x2. For a 3x3, way more work. So we're going to stick with just row echelon form, okay? So just make sure you keep your new goal in mind. This is our new goal. Row echelon form. 1s along the main diagonal. We have 0s here, here, and here. Numbers of whatever those constant values are. And we'll end up being able to solve for A, B, and C, okay? All right, so I'm going to erase this goal here, but please make sure you write that down just so I have a bunch of space, okay? So first things first, this 1 is already a 1, so that's awesome. So this is actually already taken care of. All right, let's look at what we need to do next. We want this 4 to become a 0. So let's do that first. In order for this 4 to become a 0, we're going to multiply the first row by -4, and I'm going to add it to the second row because that's going to cancel our terms, right? So if I multiply the first row by -4 and I add it to the second row of 4, -2, 1, and -5, look what's going to cancel. This is going to cancel out to a 0, which is exactly what we wanted. And now I'm just adding vertically. All right? So let's write that out. This is our new row 2. Okay, so again, nothing changed about the first row. Nothing changed. Second row now is different. So I have 0, -6, -3, and -21. I have 1, -1, 1, and -6. Okay, now the next piece, again, paying attention to our goal, we want to now turn this into a 0. We need to turn this into a 0. All right, so how are we going to do that? Well, we can take the first row and subtract it with the third row. So I can negate the first row. So really you're multiplying the first row by -1. And I'm just going to add it to row 3 to get my new row 3. Okay. So I have -1, -1, -1, -4. And I'm adding that with 1, -1, 1, and -6. You guys are going to see there are a lot of steps. I believe I have 6 or 7 steps for each one of these questions. So make sure you leave enough room. Okay. This will become a 0. Those cancel out. I'm left with -2, 0, and 10. So there is my new third row. All right, so let's fill that in. Nothing changed about the first row. Nothing changed about the second row. We're getting there though. And now I have my new third row. 0, -2, 0, and -10. Okay, let's keep going. Now I am going to clean up what I have here just to make some space, all right? So make sure you have this all written down so far. All right, so the next thing that we want to do is we're going to actually switch rows 2 and 3. That's going to be a little bit easier for us. So we're going to switch rows 2 and 3. All right, and this is what I'm going to be looking at. Nothing changes about the first row. And I'm going to switch rows 2 and 3 because it's going to be easier for us in the end. And you guys will see because we're going to do a bunch of practice with this. All right, so let me just write this out, make sure this is written correctly. And there we go. Okay, if you notice, the reason why that was part of my goal was because it's going to work out nicer if I make this -2 turn into a 1, because this is going to divide out nicer. So I'm going to multiply row 2 by -1/2. So we're going to multiply row 2 by -1/2 to get our new row 2. So now what I'll be looking at is 1, 1, 1. Again, nothing changed about that first row. I have 0, 1, 0, and 5. And nothing changed with the third row. All right, so we're getting there. We're almost there. Now I want to change this number here to a 0. So the way that I'm going to do that is I'm going to multiply the second row by 6 and add it to my third row to get my new third row. So when I multiply my second row by 6 and add it to the third row, I'll get my new third row. So let's write that out. Okay, so I'm looking at 0, 6, 0 with 30. And I have 0, -6, -3, -21. When I add these vertically, we have 0, 0, -3, +9. Okay, so now this is my new third row. So let's replace. I have 1, 1, 1, 4. Nothing changed about the second row. And now my third row is 0, 0, -3, 9. And now, guys, the very last step is we want to turn this -3 into a +1. All right, so we already took care of this 0 in this step here. Now we're turning this -3 into a +1. So the way that we're going to do that is just multiply this by -1/3 for that third row. Okay, so we'll end up with 1, 1, 1, 4, 0, 1, 0, 5, 0, 0, 1, and -3. Okay, so there you have it, guys. This is our final answer. We have this into row echelon form. So now we can go back and solve for A, B, and C. So make sure you have all these steps because I'm actually going to erase all of this and just rewrite this matrix here and use that, all right? So erase what we got. So now from our row echelon form, all right, so this satisfied our goal. We're in row echelon form. We know that C is going to equal -3. B is going to equal 5. And we have our top row as A plus B plus C equals 4. So I have A plus 5 plus -3 equals 4. I have plus 2 equals 4. So I'll have A to equal 2. So guys, there we have it. There is the equation for our quadratic. We have y equals 2x squared plus 5x plus -3. So I'm just going to write -3. Again, this came from the formula for a quadratic function. We use standard form of what I have highlighted here in blue, that ax squared plus bx plus c. So we were able to come up with the equation here. All right, I know lots of steps, but we did it. This is another way of using matrices. So there we go. There's your equation. Okay? All right, so let's take a look at a few more examples. All right, so now we have word problems with let statements. So I have the sum of three numbers is 26. The third number is twice the second. So we have the third number is twice the second. And it's also 1 less than 3 times the first. What are these three numbers? So I'm going to write my let statements first. All right, so here are my let statements. So now let's come up with our first equation. We have the sum of three numbers is 26. So when I sum all three of these numbers, I'll get 26. So I have x plus y plus z is going to equal 26. We have the third number, so z is twice the second, so 2 times y. And we have the third number is also 1 less than 3 times the first. So we have 1 less than 3 times the first. Okay, so here are my three equations. Now I have to write this so that I can write my augmented matrix. So nothing changes here. This is my x plus y plus z equals 26. I need to subtract over my 2y. So I'll have negative 2y plus z equals 0. There's no x. If I subtract over my 3x, I'll have negative 3x plus z equals negative 1. And now here there's no y term. Okay, so let's create our augmented matrix. And again, I'm just going to clean this up just to provide us with plenty of space. All right? Okay, so I have 1, 1, 1 with 26 on the right-hand side. There's no x term, so that gets a 0. I have negative 2, z, which is 1. There's only one z. And then 0 is the constant. I have negative 3 in front of x. There's no y value. And I have 1z. And our constant is negative 1. All right, so there we have created our augmented matrix. Now we want to get this into row echelon form. So let's write out our goal. Okay, so keep that goal in mind. So when I start going through this, if I look, my first number is already a 1, so that's taken care of. I don't need to do anything there. If I look even further, this is already a 0, so I don't need to do anything there either. That's good. Now, let's take a look at this negative 3. We want to turn that negative 3 into a 0. So let's do it. Let's write out our first matrix. So I have 1, 1, 1, 26. Just writing this out. All right, so now the way that we're going to turn this negative 3 into a 0 is if we multiply the first row by 3. So multiply the first row by 3 and add it to the third row. So multiply the first row by 3 and add it to the first row. So we'll have 3, 3, 3. 26 times 3 is 78. I have negative 3, 0, 1, negative 1. We're just adding vertically. Okay. And there is my new third row. So there's our 3 new. So let's write it out. All right. So we have, again, nothing changed about the first row. I have 0, negative 2, 1. Nothing changed about the second row. And now here is my third row. So now that's been taken care of. Okay, let's just keep going. I want to turn that negative 2 now, which is here. I want to turn that into a 1. So let's do that next. So in order to turn that negative 2 into a 1, we're just going to multiply our entire second row by negative 1/2 to get our new second row. All right, so let's do it. Nothing changes about the first row. Our second row is now 0, 1. I have 1 times negative 1/2 is negative 1/2, and then 0. I have nothing changed about the third row. All right, awesome. So this was taken care of now. Now we want to change this 3 here into a 0. So let's do that next. Now the way we'll change that 3 into a 0, we're going to multiply our second row by negative 3. So if I multiply the second row by negative 3, and I add it to the third row to get my new third row. So let's do it. I'll have 0, -3, +3/2, 0. I'll have 0, 3, 4, 77. And now we're just adding them. This is just 0. This is just 0. 3/2 plus 4 is 11/2. And then I'll just have 77. So now here is my third row, which is new. So let's now write that out. So we'll have nothing changed about the first row, nothing changed about the second row. Now my third row is 0, 0, 11/2, and 77. Now our last goal here is to change this here into a 1. So this is the last thing we got to do, guys. We just took care of the 0. Last thing we got to do is change this into a 1. All right, so let's do it. I'm going to erase what I have here just to clean up some space, all right? So make sure you have written down what I already have, okay? So I'm just going to erase this little area here, and we'll just continue with this. All right, so now we're going to turn this 11/2 into a 1. So this is actually pretty easy. So let's just rewrite our matrix. In order for us to turn that 11/2 into a 1, all we have to do is multiply the third row by 2/11 to get our new third row. So let's do it. We'll end up with nothing changes about the first row or the second row. So nothing changes here. And I have 0. This will be 0, 0, 1. And 77 times 2/11 ends up being 14. So there you guys have it. This is now in row echelon form. So this matrix is now in row echelon form. We've satisfied our goal. Now we just have to go back and solve for x, y, and z. All right, so again, I'm just going to clear up some space for us to actually do that. All right, so we know z is equal to 14. All right. Now we have from our second row, we have y minus 1/2 times z is equal to 0. So again, that came from this line right here. Y plus 1/2 times z is equal to 0. So I have y minus 7 equals 0. So that means y equals 7. And now lastly, to get x, we have to use this line. We have x plus y plus z equals 26. So I've got x plus 7 plus 14 equals 26. 7 plus 14 is 21. So I have x plus 21 equals 26. Subtract the 21, and I'll get x to equal 5. So there you guys have it. Your solution to the system of equations, of a 3 system of equations. We have 5, 7, 14. That's actually a point on the 3-dimensional plane, all right? So there you guys have it. If you understand these questions, you don't have to keep continuing with me. Those were the 2 main examples I wanted to make sure everyone understood. So if you just want that extra practice, you can just stay tuned and I'll go through 2 more questions on here, all right? So you don't need to, but if you would like the extra practice, stick around. All right, so our next question. We have members of a school club held a bake sale to raise money for a field trip. They sold 30 cakes and 40 pies and 200 giant cookies, which raised a total of $684.50. A pie costs $2 less than a cake, and a cake costs 5 times as much as a giant cookie. Determine the price of each baked good using matrices. All right, so first I'm going to come up with my let statements, so let's do that first. Okay, so there are all my let statements. So the first thing that we know is that they sold 30 cakes, 40 pies, and 200 giant cookies. So we sold 30 cakes plus 40 pies plus 200 giant cookies, and that total amount of money came to $684.50. Okay, we know that a pie, so the price of a pie is 2 less than a cake. $2 less than a cake. So if a cake is X, it's $2 less than that. And then lastly here, we have a cake costs 5 times as much as a giant cookie. So we have the cake, which was X, costs 5 times as much of the giant cookie, which was Z. Okay, so let's create our system of equations by making this turn into our augmented matrix. So we first know we can adjust our equation here. So my y equaling x minus 2, I'm going to rewrite by subtracting the x onto the other side. So I'll have negative x plus y plus technically 0z is equal to negative 2. So there's one of my equations. We already have the first one. The first one's always going to be the nicest one to set up. Now, if I look at my next equation, I'll have x plus 0y minus 5z equals 0. So here are my 3 equations, and we want to set this up and create an augmented matrix. So let's do that. All right, so now that we have our system of equations, our 3 by 4, we're going to create our augmented matrix. So we will have 30, 40, 200 with 684, 50 as the constant. We have negative 1, 1, 0, negative 2, 1, 0, negative 5, 0. So there is my augmented matrix. Remember, guys, what your goal is. So let's write that out. The goal is row echelon form. All right, the goal is row echelon form. So we want this to look like this. Number everywhere else. All right, remember the goal. Row echelon form is going to save us a lot more time. All right, so what should we be doing first? According to row echelon form, what should I change first? So actually, yeah, I'm going to switch row 1 and row 3. I'm going to switch these rows. So first, let me erase what I have here just to clean up some space for us. That way we'll have enough room to do the problem. Okay, so just to make our lives a little easier, yes, you could have, if you wanted to, multiply the first row by 1/30. But that is just, I don't want to even look at those fractions. So we're going to just switch rows 1 and 3. So switch row 1 and row 3. So let's do that in our next step here. We'll have 1, 0, negative 5, 0, negative 1, 1, 0, negative 2. And then now row 1 and row 3 have switched. So now we'll have 30, 40, 200, and 68, 4.50. Okay, so that took care of right here. We wanted this to become a 1, and it became a 1. Awesome. All right, let's keep going. I want to change now this negative 1 and turn it into a 0. So let's just keep going. I want to turn that negative 1 into a 0. Well, I'm going to multiply the first row by 1, and I'm going to add it to row 2 to get our new second row. Okay? So, guys, really all we're doing is just adding these rows together. So, nothing changes with the first row. And now I'll have 0, 1, negative 5, and negative 2. All right, so all I did was I just combined, let me show you, I combined these 2 rows here to get our new second row. All right, so I just added those together. And nothing changes about the third row, so we just leave it. Okay? All right, let's just keep going. Now, we took care of this. That became a 0. Great. Now I want to turn this 30 into a 0. So I'm going to multiply my first row by negative 30, and I'm going to add it to row 3 to get my new third row. So let's do it. I'll have negative 30, 0. Negative 30 times negative 5. That's 150, I have 0. And I'm adding that with 30, 40, 200, and that's 684, 50. So we're just adding those rows. This, as we wanted, was a 0, as planned. That's the point. 200 plus 150 is 350. And we have 684.50. So there's your new third row. All right, so let's write it out. Nothing changed about the first row. We kept that. Nothing changed about the second row. We kept that. And now our new third row is 0, 40, 350, and 684.50. All right, awesome. So now that was taken care of. So next, we want this to become a 1. And look, it already is a 1, so that's actually taken care of. Now, let's look at then what we need to do next. All right, I want this 40 to become a 0. So the way we're going to turn this 40 into a 0 is I'm going to multiply the second row by negative 40 and add it to my third row to get my new third row. So let's do it. We're going to multiply the second row by negative 40, so let's write it out. I'll have 0, negative 40. Negative 5 times negative 40 is positive 200, and negative 40 times negative 2 is positive 80, and we're adding that with 0, 40, 350, and 684.50. Okay? Add vertically, that's a 0. We wanted this to become a 0. We have 550. And then 80 plus 684.50 is 764.50. So now there is my new third row. So let's write it out. We have 1, 0, negative 5, 0, 0, 1, negative 5, negative 2. And now I have 0, 0, 550. And 764.50. Okay? Very last step is we want this to become a 1. And this is actually nice and easy. So we want this to become a 1. So let's do it. That's our last step. So we're just going to multiply by the reciprocal. We're going to multiply by 1 over 550 of the third row to get our new third row. So let's do it. Nothing changes about the first or second row, so all of that's going to stay the same. And now our new third row, this will become a 1. 1 over 550 times 764.50. That ends up being, when you put that in your calculator, 139. All right? So guys, there we have it. This is now in row echelon form. So now we can just plug in to figure out what X, Y, and Z are. So let's take a look. I'm just going to erase all this just to give us some space. So hopefully you have this written down already. All right? So let's take a look. Well, we know Z is equal to 139. That's established here. We have Y minus 5Z is equal to negative 2. Y minus 5Z is equal to negative 2. So I have Y minus 5 times 1.39 is equal to negative 2. And if I bring over, so negative 5 times 1.39 is Y minus 6.95 is equal to negative 2. If I just add over the 6.95, we'll get Y to equal 4.95. All right, we're almost done. Now we just want X. So let's take a look. And I'll write that down here. So now we have X minus 5Z is equal to 0. X minus 5 times 1.39 is equal to 0. Well, 5 times 1.39, as we said before, was 6.95. So now when I add over my 6.95, we'll be able to get X is 6.95. All right, so we know the cost of a cake is $6.95. So this is the cost of a cake, $6.95. We know that the price of a pie is $4.95. And we know the price of the giant cookie is $1.39. All right, guys, so hopefully you found this video helpful. Again, this was just an extra practice problem if you wanted the extra support. Otherwise, you guys can get started on that homework. All right, hopefully you found this helpful.